quickly. Right, I'll run through the Form 5 part first, and then we run through the rest. Right. So we have these lenses here. Right. We need to know the two main types of lenses: convex lens, which is convergent, and concave lens, which is divergent. Right. Concave, the middle thinner; convex, the middle fatter. Right. There are a few things that we need to know. We need to know the principal axis. That's his middle imaginary line here going through the optical center. Right, from the optical center to the point where all the rays are focused, or where all the rays converge, that distance is called your focal length. That's okay? So all your rays, you will see all these rays when they enter the convergent lens, they converge to a point. That point is called the focal point, and the distance from the optical center to the focal point is called the focal length. What is called this area here? What is called that area? Huh? No. That's where the image will be formed, but it's called the convergent. Sorry, it's called the focal plane. Right? Everything there is called the focal plane. Right, who's the host? I am the host, and this is not connected. Anyway, you're hearing okay, right? Chelsea, you're hearing? Okay, nice. Well, what you'll also recognize here is that this point, all the rays meet here. When all the rays meet, it means that you have a real image going to be formed. Okay? If you look down here, you have a divergent lens. What you will recognize is that all the rays are diverging, they're moving away. But if you're extrapolating backwards, they will meet at a point called a focal point. Okay, but the image here that will be produced is a virtual image. All right, diverging lens are thinner in the middle than the edges. They cause a parallel beam to diverge, means move away. The parallel beam appears to come from a point B. That's why it's called a virtual image. It appears to come from there, right? Right, these are all things that we just went through. The optical center is the point in which the lens through which all the rays will pass without deviation. Principal axis, Principal axis is an imaginary line which is perpendicular to the lens and which passes through the optical center, joining the surfaces of curvatures of the surface. Principal focus is the point on the principal axis to which all the rays are originally parallel and close to the axis, converge, or from they appear to diverge, right, after passing through the lens. Principal focus is the point on the principal axis to which all the rays parallel and close to the axis converge, passing through the lens. Right. One thing to notice is that the principal focus on a diverging lens is the point on the principal axis from which all the parallel rays and close to the axis appear to diverge after passing through the lens. Right. We went through all this already, right? Focal length is the distance between the optical center and the principal focus. Focal plane is the plane which is perpendicular to the principal axis, which passes through the principal focus, right? Nice. Now for some things that we have to run through. Magnification. Magnification is the height of the image over the height of the object, or image distance over object distance, right? This is V over U, right? I just want to point out something here. You may remember this from Form 5 or may not. You have a principal axis. You have your lens, right? That's a convergent lens, right? And we have a distance F here. a distance 2f. Yeah? Here's f as well, and here's 2f. So remember this, right? If you place an object here, let's say the object, I'm just making up a number, right? Let's say the object is 3 centimeters, right? This is the object. How do we obtain the thing? Start back again, right? How do we obtain the image? Anybody remember what to do? Convergent. All is convergent for now. So draw a line from top through the lens and to the focal point. All right, so that's draw it like that. Cover the up. Well, part I missed it. Hold on there. One way alone. To the middle. Although I give you some definitions, it's still called the middle. All right, I'll take that. That's now right. I'll draw it. That's now. Right, you see the distance. Yeah, I'm going to draw it as now. I'm going to draw it, right? And then from that, there's a formula called the lens maker formula that does define all of this. Just give me a minute, right? That's what my pen to charge again. I'm not sure why it's giving some of trouble. All right, so watch here. Right, so before we figure out where the image is, the distance from here to here, that distance is called your object distance, u. To work out your image, to do it via the graph, you draw a line parallel to the principal axis through the focal point. Right? That's the first way. The second way, from the top through the optical center. And then they should meet somewhere, right? My diagram is not scalar. So they should meet somewhere. And then we could figure out the image. Right? That there's the image. And the distance from the lens or the optical center to the image is the image distance. Okay, so u is your object distance, and v is your image distance. Are you okay with that? Right, there are some properties also, by the way. So they said magnification is v over u. So it gives you an idea if your image will be larger or smaller, right? But there are some properties of the image. Anybody remember them? 4 properties. Right, so let's use this as an example. This image is real or virtual? How do you know that? Because the rays meet, right? Right, the 2 rays there meet. What's the next thing? Upside down, right? Inverted, right? Right. So if you look at the object and the image, they're inverted. Okay. What else? Look at the size. Now that looks bigger. It's looking larger, right? It's looking larger, right? Rivera say by 2. I don't know how true that is, but and what's the last thing? The last thing is want to know is the position, right? It's looking like beyond 2f in this case. Okay? Those are the 4 things I need to know. This is not in the handout. Yeah? It's not in the handout. That's why I cannot turn it over. I think I have some images, but it's not there. And the formula that links all of this together is 1 on f is equal to 1 on u plus 1 on v. Remember that? Lens maker formula. Right, just copy down this one example. I give you homework. What Question? I sent in a group too. I can't believe that. Anyway, today's the last day. I won't frustrate all over. No class next week. No. Crash courses start from Saturday. Well, whoever applies next week Saturday. Huh? Applied this Saturday. Some subjects, yeah. Yeah, I'm recording the crash courses, but I'm putting them private, so I'll tell you how to get them. Right? Because we have some editing, so I might release them as yet. But I'll be recording them, but they won't be public. Because I want to edit them out and turn them into. Right, catch out fast. And then let's start to use this lens maker formula, right? Anybody remember? If the image is real, B is what? If the image is real, B is something. If the image is real, B is positive. Right, good job, Karina. And if the image is virtual, B is negative. All right, copy that down. Let's make a little note, right? So we're going to take a look at some of the problems that people have with nearsightedness and farsightedness. Huh? So what is what? M is magnification, Barry. M is magnification. All right, good. So let's take a look at using this lens maker formula, right? Here's what to do for me. Let's say the value for U, I given it some values. Just try to work out V for me now. Let's say the value for U is about 6 centimeters. U is 6 centimeters. I would like you, I'm sorry, F is 4 centimeters. See, we can find V for me. Find V and magnification. Find the V and the magnification and tell me what you get. Find V and find magnification. U is 6 and F is 4. Huh? No, you had to work out that. Yeah. Okay. All right. I say it out loud. We work. right? You can leave everything in centimeters, right? Hurry up. I want you to work out B for man. I want you to work out M. Finish? Huh? Points. Oh, you'll see the answers? Right, so it's 1 over 4 is equal to 1 over 6 plus 1 over V. You'll get 1 over V is 1 over 4 minus 1 over 6. So what's that? That's 12. You could use 12. Yes, so that's 1 over 12. So V is 12 centimeters. So the magnification, so V, if V is positive 12, it tells you that the image is what? Real, right? And the magnification is V on U, so that's 12 over 6. So basically, this image here should be twice as big, right? And it should be twice as far away from the lens. Okay, nice. All right, so good. That's a quick little review on your CSEC stuff. Taking this off, right? Right. So magnification is the image height over object height, image distance over object distance, right? Then there's something new called power. Power is 1 on the focal length, right? But the focal length has to be in meters. Okay. The SI unit of power is the diopter, capital D. Converging lens have a positive power, diverging have a negative. But for those who write in, make a note of that. Power is positive, convergent, negative, but divergent. So if you have a divergent lens, 1 on F will be negative. For converging lens, 1 on F will be positive. Nice. You have your lens makeup formula here. 1 on F is 1 on U plus 1 on V. Right, we talked about this already. If the image is real, right, then V is positive, V is negative if it's not, right? Here we have a small example. You could just try that quick. Today could be a short class if we finish up fast. We could finish before 6:30. Good. If all the work fast. Find those 3 things there, please. Find the position, nature, and magnification. Finish? Right, message your answers. Quick. When they say nature, what do I mean? When they say nature, what does that mean? If it real or virtual. Oh, yep. Ready? Last minute, yeah? All right. Last one. Last let's work it out, right? Right. So they give you the object height, right? That's the object height there. And they give you the object distance. They give you the lens of power 4, right? They give you the power of the lens, right? So we know that 1 on F is equal to 1 on U plus 1 on V, right? Find the nature and the position. So the power is 1 on F. So we know that 4 is 1 on F. The object distance is 1 over 0.125. Once you're working with power, you have to work in meters earlier. Okay. And then plus, don't know why this thing giving so much trouble. Plus 1 over 1 over V. Okay. That's okay? And then you rearrange the formula. I use my finger, I don't know what's going on with this. Right, so 1 on V is equal to 4 minus 1 over 0.15. How much is that? What I get there? What do that? I won't be minus. It minus? Oh, okay, okay. Oh, yeah, 4 minus that value. Okay. Minus 0. What? So 1 over V, this value is what? Minus? Minus 2.66. So therefore, V is equal to minus 1 over 2.66, which is minus what? 0. I ran out of space. I put 0.4, right? Negative 0.4. So it means that it's what? It's virtual. How you find magnification? Something wrong with the screen or no? Magnification is equal to the V value, right? Which is minus 0.4 all over 0.15. Right, so that's around 2.5. That's around 2.5. I cannot round off, right? That's around 2.5, right? So the magnification somewhere around there, right? Trouble? Trouble? Where did wrong? Right? So you get F as a quarter. So you put 1 over quarter. Oh, you just put 1 on, okay. Yeah, but you see, they already give it out, so you might as well work with that value. Right? So I just book it 1 on F. All right. I'm not sure what's going on with my pen. Right? So that's basically how you handle questions like this, right? You plug in your 1 on F. Remember, they gave you 1 on F, right? Because power is 1 on F. So I simply replaced 1 on F with 4. And well, they gave me U and so on. Please remember that these values must be in meters, right? If you're working with power, everything must be in meters, right? If you're just working with F and U and V, it could work in centimeters, right? But make sure when you're finding your value for P, for power, it has to be in diopters, which is in meters, m to the minus 1. Right? Sorry about the handwriting, everybody pen now working. All right, there's one more part to finish. So they have the values here, 0.35, negative, virtual, and so on, right? Just try this last one here, coming up, please. Find the power and the position of the image. Last one. Find the power and the position of the image. Finish? All right, let's see if the pen will work here. All right, so let's just see how it will work out, right? So the object is placed 0.4 meters away, so U is equal to 0.4 meters from a divergent lens, which means our power should be negative, right? Our power should be negative. And the focal length is equal to 0.3 meters most likely, right? Find the power. So we know power is equal to 1 on F, but because it's a divergent lens, we point at negative sign. So that will be negative 1 over 0.3, which is about 10 on 3, negative 10 on 3, 3.33, sorry, negative 3.33 diopters, right? Part 2, they want the position of the image. So we know that 1 on F is equal to 1 on U plus 1 on V. Remember, 1 on F is minus 10 on 3, right? We just found that out, right? 1 on F is minus 10 on 3, and U is 1 over 0.4. So you want to make B the subject. So 1 on V is equal to minus 10 on 3 minus 1 over 0.4. Work it out and you can flip the answer one time. You should get something negative because it's a divergent lens, right? How much you got? Do we get to flip it over? Flip it over already? Try and flip it over one time. Huh? Minus 171. Okay. Okay, so it will look something like that, and the image is virtual. See that, right? The image is virtual. Okay, nice. So that's just see some of the things that we need to know, right? So everything right there, actually. Right? Any questions online? That's some of the calculations, right? You'll get something like that. Right? Let's run through some of it. Some of it I'll make you read, but I want to run through some of the important things. So ray diagrams are constructed. There are 3 types of rays, right? And we talked about this already, right? This is where you come up with the ray diagram. This ray diagram here, right? You draw one parallel to the axis through the focal point, one through the center, and so on. Okay, here's an example of where the divergent lens, right? Where the divergent lens produce something virtual. Okay. This is the eye. You don't really have to be able to really have to draw it, right? You just have to have an idea of where everything is. If they ask to explain anything, right? You have a cornea, your pupil, your retina, and so on. It gives it the function. Cornea does the refraction. The pupil allows light to enter, and the retina is light sensitive. Okay. You also have all of these here, right? One of the important things is the ciliary muscles. It controls the shape of the lens. Okay. Are you okay with that? Right. One of the important things though is the defects of the eye, right? I think I have that quite on the next. Oh gosh, look at what happened here. Anyway, we'll get to read that, right? So an inverted image is formed on the retina of the eye by successful. I think you're in trouble again, boy. I know what's going on with this thing now. I'll have to get a new pen. All right. An inverted image is formed right here, right, Claudia? An inverted image is formed on the retina of the eye by successful refraction at cornea, the aqueous humor, the lens, and the. Let's spell that wrong. So what was supposed to do? Right. The vitreous humor. That's the one in the back. Right here. Vitreous kind of means in the back. Right here. The vitreous, oh, I spell it right. The vitreous humor. Most of the refraction takes place at the air cornea boundary because of the difference in optical densities of the pair of media. The information is then sent along the optic nerve to the brain. To focus upon objects that are different distances from the eye, the shape of the lens is altered using the ciliary muscles. This alters the focal length at the lens. The process is called accommodation, right? So you have to be able to write this whole thing here if they ask you what's accommodation. All right. Near objects, the ciliary muscles contract, lenses thicken, and the focal length decreases. The image of near objects formed on the retina. For distant objects, the ciliary muscles relax, the lens becomes thin, the focal length increases, and the image of the distance on the object form on the retina, right? So they're showing you here how the ciliary muscles alter the retina. Okay? Sorry, not the retina, alter the lens. For the image to be formed on the retina. Huh? The lens is the kind of lilac thing there, yeah. Okay? Right, here's two important things. The normal human eye can see objects in focus in the range of 25 centimeters to infinity, right? Infinity means very far. The near point is the closest point to the eye at which the eye can focus on image, right? It's not the same for everyone, so we had to pay attention, right? But the near point is the closest position to the eye at which the eye can focus on image on the retina. It's taken as 25 centimeters from the eye. The far point is the furthest point at which the eye can focus the image on the retina and it's taken as infinity. But of course, we know the value is not really infinity, right? It's like 600 centimeters for some people and things, right? Right, so the value does vary slightly. The depth of field is the distance between the limits around the object position where the eye can acceptably focus on the image of the retina. The depth of focus, on the other hand, is the distance between the limits around an image on the retina where the eye can produce acceptable focus images on the retina. Shucks, a picture missing. The depth of field and depth of focus depends on the diameter of the aperture of the iris. Okay. All right, I have a picture for you. That'll be too hard to draw now, right? All right, I'll have to send that there for you. All right, so these are three of the defects of the eye. The first is short-sighted, myopia. You have long-sighted, hypermetropia, and then you have astigmatism, right? Huh? What's that? I know it. I end up squeezing it in. I feel that's why the image didn't show up. So what is short-sightedness, right? You all should know this from Form 1, right? The inability of the eye to allow the lens to relax, or the eyeball is too long, right? The effect is that the image of a distant object formed in front of the retina. So if you're short-sighted, the image is formed in front of the retina, and the far point is narrower than infinity. Okay? How do you fix it? You use concave lens. So the concave lens will diverge the light before it enters the eye. Lens produces a virtual image at the far point of the eye, right? So short-sighted people, they use concave lens. All right? Long-sighted, right, is the inability of the eye to make the lens thick, or the eyeball is too short. The image of a near object formed behind the retina, right? The near point is further than 25. So when your near point is further than 25, what you have there is long-sightedness, right? In this case, you use convex lens. Convex lens converges the light before it enters the eye. The lens produces a virtual image, right, at the near point of the eye. So let's make a note of that. Both of them. That's something important, right? The lens produces a virtual image at the far point of the eye. That's for the short-sightedness. For short-sighted, concave, right? Just make a note. For short-sighted, you use concave lens, and it produces a virtual image at the far point of the eye. Right? And for long-sightedness, we use convex lens, and the lens produces a virtual image at the near point. Right? That's if you're long-sighted. Very important, huh? Right? This is the most important thing here, because this is the most popular question. Questions that they give us are for long-sighted people whose near point is further than 25 centimeters. Are you okay with that? So it's very important. Once you see that the near point is further than 25, this person long-sighted. All right? Everybody okay with that? Right. Let's just take a look at astigmatism quickly. Oh Lord. Astigmatism is uneven curvature of the cornea. The real hard boy. Right? If you don't know it, you'll carry it. The difficulty in focusing light rays from objects in different planes at the same time. Right? I really apologize about that earlier, but it's an exercise. Right? So you could practice memorizing it and then come in here and see if we can figure it out. Right? Right? Cylindrical lens refracts incoming light rays into a single plane rather than a point before the eye lens system completely focusing to form a sharp image, right? So you basically use cylindrical lens to correct astigmatism. So you have. So if you take off your glasses, you can still see. It's like fully blurry. Like if you take off yours, it's supposed to still be long-sighted, right? Okay. Yeah, because you're supposed to be able to read certain things still, right? Right, and then cataract is well the agent thing, and all you can do is just remove it via surgery, right? Right, homework we read up on the simple camera, right? Read up on the simple camera for homework. All right, there are some questions though that I want to look at. This is a past paper, right? This is a past paper on lenses. Just give me 1 second while I look for it. I had it here recently. Waves. There are waves inside of me. Right, where is that question? Oh gosh, I must go and go back up. Oh no. I must look for this thing now. All right, here's one. Try this one here. Very similar to the past papers, right? And I will go get the next one and get past paper fast. It's the last thing we do and be done. Right, and I'll see in the image here. Something going on with this iPad. I do it will give no trouble later on. Crash course time. All right, take a little read here. We want to try to determine the power of the lens. Right, try that, please. I just want to get the pass paper pass. Oh, yeah. Right done? I'll have a clue. Right, so I want to help you with this a little bit. Anybody can do it? Try it quick. I'll give it 2 minutes again. So the formula basically uses the lens maker formula, right? Right, but the thing I made you write down something, right? This person long-sighted or short-sighted? Right, and I told you something. Where's the image form? At the near point, right? At the person near point, right? Is it real or virtual? And good. What type of lens is person supposed to have? So think about it and try. Think about it. I can't do this now, but let's try it. Come on. If you could do it, it'd be really nice. right? Your question will look just like this, right? Just the word that change up in numbers on it. All right, so that's what I came up with now. So we know for sure, right? Hopefully the pen work it, work well fast here. 1 on F is equal to 1 on U plus 1 on V. Our objective is to find the power of the lens, right? So we are technically trying to find P. But where is you all recognize here that the near point is 40, right? The near point is 40 centimeters. So this person appears to be far-sighted, okay? Long-sighted, sorry. Right, so what that means is here's what they want. They want to put the object, at 25 centimeters. So what that means is that the image, which is virtual, is formed at 40 centimeters. That's okay? So your image is at 25 centimeters. So let's convert that to meters one time, because we're working out P, right? And then the image is at 40 centimeters because as we learned a little while ago, if you're long-sighted, your image is formed at the person's near point, and it's a virtual image. So it will be minus 0.4 centimeters, right? So your power is equal to 1 over 0.25 minus 1 over 0.4. How much is that? How much is that? How much? 1.5. So the power is 1.5 diopters. Are you okay with that? So let's just read the question over to make sure you understand, because all the questions are just like this, right? They want to determine the power. The person's near point is 40 centimeters, and the person's far point is 150 centimeters, right? We recognize that the person is long-sighted because the person's near point is much further away than the normal near point, 40 centimeters, right? So we want to get the power of a lens required to put the reading book is the object, 25 centimeters from the eye. So the object distance we are working with is 25 centimeters. And the image distance is where it's going to be formed, and it's going to be formed at 40 centimeters. And the reason I put it negative because it's virtual. Okay, so you plug in U and V, and then you solve for 1 on F. Are you okay with that? Chelsea, Karina, Bear, Eden, Rajiv, everybody? You're okay with that? So it's important to identify if the person is short-sighted or long-sighted, right? This one doesn't have a calculation in 2019. Actually, yeah, it has a calculation. This is 2019. Let's chance squeeze in one more and be done. All right, any questions? Andy, you okay with that? Right, we have to answer the first two parts and then find the power. This question asks it to draw long-sighted and how to fix it, right? Or short-sighted, how to fix it, right? But I ignoring that, right? How much you got? Wait, how you do find it? Do the video? And pause the answer. No power. I tried fast. So what does the grandma have? She has short-sightedness. Finish? Good, everything on die here. Right, so the grandmother's defect is what? The grandmother is short-sighted, and the type of lens is he? To fix it, concave lens. Right, work on the power faster and we done.